This is a dodo. I'm gonna go ahead and say you've probably heard about them. They've sort of become a running joke in the biology community, and most of what people know about them can be boiled down to two things. One, they were incredibly stupid, and two, because of that, they're now extinct. Now, it's common to say you're as dumb as a dodo, or when something dies, we say they went the way of the dodo. But to be honest, that's not really fair. Standing over 3 feet tall, these were some pretty amazing birds, and to say they went extinct simply because they were stupid not only does a huge disservice to what were some truly incredible creatures, but also ignores the larger forces at play behind the dodo's demise. The real story behind the disappearance of the dodo is far more complex than bird stupid, and is really just a single instance within a trend that's far more widespread than most of us realize. Now, the same forces that drove dodos to extinction threatens to drag more and more species to the same fate. And if we want to fight against this and prevent even more wonderfully unique species from disappearing forever, the first thing we need to do is know what the actual problem is. So let's do the best we can to learn from the past and figure out what actually drove dodos to extinction. In my opinion, the best way to start learning about dodos is to look at the environment they were native to. Lucky for us, this is pretty easy, as it was here in the middle of the Indian Ocean on just a single island known as Mauritius that the entire dodo population once lived. It'd be the isolation afforded to the birds on this island that would give rise to the dodo and ultimately lead to their demise. You see, islands work differently than continents. Whoa, hey. While a continent may move or change over eons, by virtue of being a huge, basically permanent landmass, they've always had large areas home to large and diverse populations, all of which need to be able to survive the presence of every other animal. These massive competitive arenas with extended natural histories give continental animals enough time and pressure to evolve better and better strategies for survival. Islands, on the other hand, are typically much younger than continents, and when they first peak above the ocean, they don't have any life on them whatsoever. That's exactly how Mauritius, along with the rest of the Mascarene Islands, got their start. Their history began roughly 140 million years ago, as India broke away from Africa. For a time, we can see what would become Madagascar stayed connected to India until about 100 million years ago, when a new rift in the ocean floor split them apart. This break in the crust unleashed a huge bout of volcanism, which first built up the Chagos-Laccadive Ridge off southern India before eventually producing a chain of seamounts at the bottom of the ocean, the Mascarene Plateau. Only a few of these ever managed to break above the water, but the ones that did, like the Seychelles, Rodriguez, Reunion, and of course Mauritius, did so having absolutely no prior natural history and no native species. For a time, these islands would have sat as lifeless rocks in the middle of the Indian Ocean. But pretty fast as igneous rock can turn to soil, life could begin to take hold. Transported either by wind or by ocean currents, plant seeds have a relatively easy time finding new islands. Volcanic soils are typically rich in nutrients, and so within no time these once barren islands were transformed into Edens, where plants could gorge themselves on the fertile virgin soils and bask in the moderate oceanic climate. But as we've learned in past videos on biogeography, plants and animals have very different rules when it comes to distribution. For plant seeds, what's as easy as floating on the water or drifting through the air is a much harder task for animals. Unless a land animal can swim the hundreds of miles from the nearest mainland, then islands like these are completely off limits. And actually, animals follow very specific and very regular patterns when it comes to island biogeography that all boil down to two factors: how far away an island is from the mainland and how big that island is. An island's distance from mainland understandably determines the rate of colonization, or how many species can make the journey across the ocean, while an island's size typically determines the rate of local extinction, or how many species can manage to survive once they arrive. When I was learning about this in school, the textbook example we were given was a study on the number of lizard species found on the different Caribbean islands. Smaller islands like Redonda or Montserrat harbored less than 10 different lizard species, while bigger islands like Puerto Rico and Cuba could host upwards of 50 to 100. Plotting the number of species against the size of the island, a very clear relationship becomes apparent, with the size of each island directly corresponding to the number of species it contains. What all this means for an island like Mauritius that's both relatively small and distant from any mainland is that few animals can manage to reach its shores, and even fewer are able to successfully colonize it before going locally extinct. This simple reality has left Mauritius, and really many of the world's islands, rich in plant life but poor in animal life. Well, that is except for one kind of animal: birds. Thanks to their unique ability to fly, no matter how small, how rocky, or how isolated any given island may be, mark my words, birds will find it, they'll nest on it, and if given the choice, they'll never leave. And that's exactly what happened here approximately 4 million years ago, when a relative of the pigeon came to rest on some of the only land in the Indian Ocean. What these pigeons found was a veritable paradise full of bountiful sources of food and completely devoid of predators. Naturally, these pigeons stayed here and immediately began adapting to this new environment. The plentiful food on the island allowed the birds to grow from less than half a foot in height to an astounding 3 feet or 1 meter tall. Their beaks transitioned from small, sharp, accurate tools meant for eating seeds to large, bulbous beaks, better suited for eating the fruits found on the island. This made dodos one of the biggest animals in their environment, second only to the great tortoises, and more capable of making use of the resources at hand than any other, giving them essentially the dominant role here on Mauritius. But it's important to remember that evolution is always a game of exchange. And whatever new adaptations arose to help the dodo prosper here came at the expense of adaptations that had allowed their ancestors to survive back on the mainland. Dodos' bigger bodies, for example, made them incapable of flying, and so their wings atrophied into useless appendages, leaving them unable to effectively escape anything they one day may need to. Even worse, these changes reached all the way into their brains, affecting their very psychology over time until they had lost all instinctual fears. Behaviors like fleeing from danger that had once been necessary for their ancestors to avoid becoming prey were no longer selected for and fell out of use until the idea of flying or running away was completely forgotten. It was this lack of fear that later people would find so off-putting about these birds, leading them to rather rudely assume them to be, for lack of a better word, stupid. While these losses may not have been a problem for the birds on their island paradise, their prolonged existence now depended on their habitat remaining isolated. But as you've probably been able to guess by now, this isolation wouldn't last forever. And while Mauritius may very well have been safe from predatory animals naturally colonizing it, eventually a new kind of colonialism would leave no corner of the world untouched. While Arab traders may have visited the island as early as the 10th century, it wouldn't be until the beginning of the 16th century that Portuguese sailors moving spices between Asia and Europe would recognize the value of this island as a good stopover point along their 20,000 kilometer long voyage. But even the Portuguese never had any real ambition of actually settling on the island, and it wouldn't be for another 100 years before other Europeans, the Dutch, tried to establish permanent settlements here in 1638. What these Dutch settlers found when they arrived was a population of giant birds, completely oblivious to the concept of being hunted, to the point where you could walk right up to them and beat them with a club. So naturally the Dutch did, well, exactly that. But surprisingly, even hunting by humans isn't considered the main cause behind the dodo's extinction. No, the true danger came in what the Dutch settlers brought with them, namely dogs, cats, rats, pigs, and for some reason monkeys. Released to roam freely across Mauritius, these animals must have experienced something very similar to what the ancestor of the dodo had experienced when they first arrived, a land brimming with easily attainable food. Only now that food wasn't the fruits growing on the trees, but rather the dodos themselves. And so, despite the fact that less than 50 people had settled on this island by this time, the plentiful supply of defenseless birds allowed the animals released here to multiply rapidly, wreaking havoc on the dodo population. Add on top of this severe habitat destruction to make way for farms, and it was less than 30 years before the dodo became exceedingly rare on the island. From the first Dutch settlements in 1638, the last confirmed sighting of the bird came in 1662, though estimates of when the species was completely wiped out range from 1688 to 1715. Either way, what we can see is that in almost no time at all, when confronted with mainland species, these birds that had grown accustomed to the easy island life were simply no match. Ironically, by this time, even the humans on the island were forced to leave, as their settlements became overrun with long-tailed macaques, which destroyed everything in it. Which I guess technically means even humans were driven locally extinct here by the very animals they had introduced. And so if even humans couldn't cope with the damage they had done to this fragile environment, how could dodos have been expected to do any better? So overall, what we can see is that dodos were driven to extinction not because they were stupid, but rather because they were non-competitive and had grown soft in the easy island environment that was pre-colonial Mauritius. The reason we shouldn't judge these birds too harshly is that, well, this happens all the time. Even if we keep looking just at the small island of Mauritius, we'll find that while dodos were definitely the most popular bird to have gone extinct here, they were by no means the only ones. Included in this unfortunate list is also the Mauritius shelled goose, Mauritius duck, Mauritius wood pigeon, Mauritius turtle dove, Mauritius blue pigeon, the red rail, the mascarene coot, Mauritius night heron, the Mauritius scops owl, Newton's parakeet, Mauritius gray parakeet, and the broad-billed parrot, all driven to extinction at the same time for the same reasons on the same island. But I don't want you to think this is an issue special to the unique environment of Mauritius. Even the closest relatives of the dodo living on neighboring islands like the Rodriguez solitaire and the Réunion ibis have also been lost thanks to human-introduced predators. So how can so many species so specially adapted to their environment simultaneously be so vulnerable? Well, now it's time for us to look at the big picture. Collectively, the effects of island biogeography are given the name island syndrome, though within this prognosis are a number of specific traits. What all these birds suffered from is called island tameness, an adaptation so widespread that no matter the location or the evolutionary history of the species, whether it's dodos on Mauritius, the Javan lapwing, Lyle's wren in New Zealand, a Moorea sandpiper, Laysan rails in Hawaii, the spectacled cormorant in the Bering Sea, the great auk of the North Atlantic, the Ascension crake, the St. Helena rail, or the Tristan moorhen, all fell victim to the same trap, all having lost their ability to fly and avoid predators, only to suddenly need them once again. But island tameness is only one of several alterations to animal physiology that isolation can select for. If you'll remember, besides their docile nature, another notable aspect of the dodos was their colossal size. It was the combination of plentiful food without the threat of predation that allowed them to transform from light and agile creatures capable of evading danger to, well, definitely not that. This trend is known as island gigantism, which dodos definitely exemplify, but they're by no means the most extreme example of it. And actually, we don't even need to look that far to find examples of even bigger birds. Until recently, on the island of Madagascar, similar conditions to those of Mauritius allowed for the evolution of the tremendous elephant bird. Measuring over 3 meters tall, these birds would have towered over even similar birds like the ostrich and stood twice as tall as an average human. But even this wasn't enough to spare the elephant bird from the same fate as the dodo, having gone extinct by the year 1200 CE, not coincidentally around the same time human populations really took off on the island. But ironically, the exact opposite can happen too. You see, if a mainland animal's strategy to avoid predation was to grow big instead of growing small, then the predator-free environment of an island will eliminate the need to maintain such a large body size. Perhaps the best example of this comes not in the form of birds, which all tend to start out small anyway, but rather can be found in the islands of the Mediterranean Sea. Here, the relatively calm waters and short distances from the coast allowed multiple groups of full-sized elephants to colonize many of the islands here. But what might have been a land with plentiful food for small birds ended up being quite a limited food supply for the behemoths that are mainland elephants. This, combined with no longer relying on their size to fend off the many predators of Africa, led to the island elephants developing much smaller bodies, an aspect of island syndrome called island dwarfism. What I find even more interesting is that despite being within virtually the same region, because the elephants on all these different islands were not only isolated from the mainland, but also isolated from one another, they all ended up becoming their own different species, resulting in the Sicilian dwarf elephant, the Maltese dwarf elephant, the Cretan dwarf elephant, the Cyprus dwarf elephant, the Naxos dwarf elephant, and the Rhodes dwarf elephant. Unfortunately, unlike island gigantism, which can actually make its species more resilient to invaders, island dwarfism almost always makes its victims more vulnerable. That's why none of these dwarf elephant species have survived into the modern day, all having gone extinct roughly around the same time humans began to settle the region. But even humans are animals too, meaning not even we are safe from these evolutionary forces. Within the Malay archipelago, for example, a number of people groups settled onto islands such as this one, Flores, and kept contact with the outside to a minimum. Like any other large animal, after enough time with limited food resources and without the need to fend off large predators, shorter body sizes became more beneficial than tall ones, resulting in people groups like the Rampasa, who averaged less than 5 feet in height. Altogether, what we can see is that the natural history and biogeography of islands lends them to becoming fascinating laboratories of evolution, capable of producing some of the most amazing and sadly some of the most vulnerable creatures in the world. But okay, here's where things get really interesting, as this doesn't just apply to islands. You see, what we've been talking about so far are the quirks of island biogeography, but another term used to describe the same exact phenomenon is insular biogeography, as these same trends can be observed in any insular or isolated environment. So places like lakes, mountaintops, desert oases, caves, seamounts, and more all act essentially as islands, detached from their respective mainlands. And okay, while I can't go through examples of every insular environment and their effects on their native biology, understanding the relationship between isolation and speciation reveals to us just how great the potential for biodiversity is on this planet. But even more than that, as you might have noticed, many of the animals mentioned are either already extinct or are highly vulnerable to becoming extinct, revealing just how threatened many of the world's most unique species are in modern times. I mean, it took dodos less than 100 years to be completely wiped off this earth, after having lived on this island for millions of years, during which time they endured volcanic eruptions, ice ages, and tsunamis without succumbing to extinction. In the end, dodos and many other island dwellers were victims of their own geography, animals that only made sense in an age before humans. And while dodos may be gone forever, there are still many other unique species from a wide array of isolated environments that are just barely managing to stay alive. The first step to protecting what amazing animals that remain is to realize that no, they're not stupid just because they're easy to kill. Unless we want to live in a world where the only animals left are the ones that are hard to get rid of, then maybe it's time we change the narrative about how and why so many spectacular island animals actually went extinct. Hey everyone, I hope you all enjoyed the video. To be honest, this one was tough for me as the scope of biogeography is just so vast that I couldn't fit everything I wanted to into just a single video. So I've decided to make a series out of this and explore some more interesting avenues life has taken in isolated places. Next, we're looking at not only isolation, but isolation in an extreme environment. So make sure you subscribe so you don't miss it. Embarking on a multi-video series is a daunting task and one that I wouldn't feel confident in doing if it weren't for my patrons. Not only do they ensure that I get a steady source of income, but when I asked them about doing this, they gave me the encouragement I needed to feel confident about actually getting started. So if you enjoy these videos and want to see me and the channel continue endeavoring to make better and more interesting videos, then please consider checking out my Patreon. The link should be right here. Yeah, other than that, I think I told you to subscribe already, so I'll just tell you to like the video. The notification bell is important too, so click on that, and I'll see you next time. Thanks.